anode and cathode. So obviously anode will be someone which wants to get off. The anodic metal will be something which is easier to oxidize. The cathodic metal will be which is easier to reduce. So metals on the upper side, they have lower SRP, and if they are having lower SRP, obviously they are going to be used as the anode. So please write with me. Metals on upper side have lower SRP. Therefore, used as anode. Metals on lower side have higher SRP. Therefore, used as cathode. Right. So if the SRP is higher, then obviously it will be easier to reduce, and its reduction potential will be higher. I'm giving you a question. From the following pairs, choose anode and cathode. For example, if I have nickel and silver, so between nickel and silver, which will be anode and which one will act as cathode?
Nickel will be cathode.
बताइए which comes upper, like which comes before and which comes later on the electrochemical series? वो बताइए आप. Yes, Rishita.
Nickel comes first, then silver.
तो जो पहले आ रहा है अपर साइड हो गया ना, अपर विल बी एनोड, लोअर विल बी कैथोड, राइट?
Yes.
Anode and cathode. That means lower SRP. Lower SRP is of nickel, and then cathode will be having higher SRP, Ag. इन दो का बताइए. मैग्नीशियम, लेड, आयरन एंड एल्यूमिनियम.
Magnesium will be anode and lead will be cathode.
Okay. And
Aluminum will be anode, iron will be cathode.
very good. Fourth, for prediction of feasibility of reaction. टॉपिक लिख लीजिए तो बताइए, then I will explain it.
Done, sir.
They have given you some, let's suppose they have given you a reaction like this. Copper 2 positive plus Ag is giving you copper plus Ag positive. Don't worry about balancing the charges. Don't worry about balancing the charges. They're asking whether this reaction can occur or not occur. So by the way, they can also give you something like this. Rather than writing copper 2 positive, they can give you CuCl2 plus Ag gives Cu plus AgCl. यहाँ पे वही हो रहा है ना, दिस इज इन +2 स्टेट, कॉपर यहाँ पे 0 पे आ जा रहा है, Ag यहाँ पे 0 पे है, यहाँ पे +1 पे आ जा रहा है, राइट? So they can also give you in the form of ions or they can give you in the form of salt. They will ask you whether this reaction can occur or not occur, right? So what I will do, I will write two things according to reaction and according to electrochemical series. What is the meaning according to reaction and according to electrochemical series? Please. ध्यान सुनिएगा ऋषिता, है ना? ध्यान सुनिए ऋषिता. What is happening with copper? It is getting oxidized. Tell me.
Yeah, it's getting
Copper क्या हो रहा है? 2
reduced.
plus से 0. It's getting reduced. What about Ag?
Ag is getting oxidized.
That means copper has higher reduction potential than Ag. That is why, na? If according to the reaction, copper 2 positive will reduce in the presence of Ag. है ना? But Ag positive will not get reduced. Na? The reverse reaction is not happening. Ag plus is not getting reduced to Ag in the presence of copper. What is happening? Copper 2 plus is getting reduced. That means SRP of standard reduction potential. Hai na? We are talking about E naught. If I talk about the E naughts, E naught is always standard reduction potential. According to this reaction, copper has higher standard reduction potential than Ag. Will you be able to identify this, yes or no? Please tell me with a reaction that according to the reaction, which E naught, whose E naught is higher? इतना कर लेंगे आप, है ना?
Yes, sir.
But what about electrochemical series? According to electrochemical series, whose reduction potential is higher, copper or silver series? Which comes lower? Because we start with lithium negative and then we slowly move towards positive. बीच में मिलता है hydrogen 0.
Copper comes
So,
after. Copper comes before Ag.
so Ag will be having higher, no?
Yes, sir.
According to electrochemical series, silver is having higher reduction potential than copper. ठीक है? So
Yes, sir.
this reaction cannot occur. Makes sense? According to reaction, they are saying opposite thing. The reaction is saying a story in which copper is having higher reduction potential, but the reality is Ag is higher. Ag is having higher reduction potential. If Ag is having higher reduction potential, the reverse reaction will be possible. Not what they have given us right now, copper 2 plus Ag. For example, Fe plus copper 2 positive gives Fe2 positive plus copper. In this case, according to the reaction, copper is getting reduced. So copper has higher reduction potential than Fe. And according to electrochemical series also, like लेके बारात गाना मजे से आया, वंदन कर फेंक दे, फेंक आ गया पहले. Copper will come in chapa. So late, right? It is going to have positive. Fe is having negative SRP. Copper is having positive SRP. According to the electrochemical series also, copper is having higher SRP than Fe. When both of these are matching, like the reaction is saying the story which reality is also saying, the reality is the electrochemical series, then this reaction can occur, this reaction can occur, this reaction will not occur. बात समझ में आ गई आपको, है ना? बताएं.
Yes, sir.
So tell me what this is saying. 2 positive plus lead gives you Pv2 positive plus zinc.
So the reaction can't occur.
Reaction will not occur because manjan kar फेंक दे है ना, according to the reaction what is happening, they are saying zinc is having higher reduction potential than Pb, but in reality zinc comes before lead. Zinc comes in manjan kar फेंक दे and lead comes just before hydrogen, है ना. It is having very small negative SRP, right? Zinc is going to have higher SRP, higher negative SRP. So in reality, what happens? Zinc is having less SRP than Pb. That's complete value. That is why this reaction will not occur. Fifth लिखिएगा. Predicts whether a metal can liberate hydrogen gas from an acid. ठीक है, from an acid. ठीक है, नंबर 1. When acid is going to be present, ध्यान से सुनिएगा, जब acid present होगा, then one reaction can occur, that is H plus electron. The H plus from the acid can get reduced to half H2. अब तो सीधा हम H2 लिख देते हैं ना, H2 गैस जो 2 कर देते हैं, H2 कर देते हैं. ठीक है. The SRP of this reaction is equal to how much? Yes, Rishita. SRP of this reaction is equal to how much?
So 1 point.
सोचिए थोड़ा, आपको पता है? अरे कितना नहीं पता है आपको, नहीं पता, ये बताइए पहले.
नहीं पता सर.
तो इलेक्ट्रोकेमिकल सीरीज बताइए हमको. यू मस्ट हैव मेमोराइज्ड ना a bit of electrochemical series.
Not the whole thing, sir, but only the starting.
Still
Till
लेके बोलिए तो,
element
क्या याद है आपको?
um,
लेके बारात
lithium.
खाना मजे से आया, है ना,
हाँ,
मंजन. नो अच्छा, ऐसे नहीं, ऐसे बता दीजिए.
लेके बारात खाना मुझे से आया. लिथियम.
लेके बा
लिथियम पोटेशियम इज लेके, बारात इज बेरियम,
हाँ,
खाना कैल्शियम एंड सोडियम, मुझे मैग्नीशियम से strontium I think,
strontium,
and then iodide
iodide
aluminum.
aluminum. After that,
Yes. So after that I have to read it.
मंजन कर फेंक दे, कोई निगाहें सुंदरी प्यार भरी, हाइड्रोजन जीरो छापा. रिमेम्बर है? हाइड्रोजन
Hydrogen is zero.
zero.
Chop. Yes, sir.
So reduction of hydrogen is happening, na? SRP will be zero. Also, this is the
Yes.
reaction of standard hydrogen electrode that we learned in the last lecture. Standard hydrogen electrode is also going to have zero. Right? We
Yes,
have
sir.
assumed it to be zero. Yeah.
Sir.
Now, another reduction can take place when you add a metal is metal with n positive charge, some positive charge, will eat an electron and give metal solid. Now, the SRP of this reaction will either be positive or it will be negative. That's negative. If the SRP of this reaction is positive, then between these two reactions, SRP to zero, जो ज्यादा होता वही होगा. Both of them are what having reduction is happening in both the cases. But if the SRP of second reaction, reduction, the metal's reduction is higher, it is more positive, then what will happen? The second reaction will occur. If the SRP of metal is negative, that is, it is lower than the reduction potential of hydrogen, then the first reaction will occur. Does this make sense? Yes or no?
Yes, sir.
दोनों दोनों पॉसिबल है. कोई होगा, कोई एक कौन होगा जिसका रिडक्शन पोटेंशियल ज्यादा. If the reduction potential of metal is positive, that means higher than greater than zero, then the second one occurs. अगर negative होगा तो one. Right? So please write if SRP of metal is higher than zero, then metal will be reduced and H2 gas and H2 gas will be liberated. H2 gas will be liberated. That is higher, no, will not be liberated. No, is higher than will not be होगा ना. तो metal आएगा, will not be. That is छापा elements. छापा एलिमेंट्स में रिडक्शन किसका हो जाएगा? मेटल का होगा, H प्लस कंज्यूम का. If SRP of metal is lower than zero, then H plus will be reduced and H2 gas will be formed. That is when you are going to have the wedding elements. वेडिंग एलिमेंट समझ गए ना? लेके बारात, गाना मजे से आया, लोग बारात आ रही है, मंजन कर फेंक दे एंड एवरीथिंग. Got till here? Yes or no?
Yes, sir.
This is a nurse situation. The nurse equation क्या है? It gives the relationship between electrode potential temperature, and concentration of ions. Okay, so we have just now we have seen only the E naught. That means at standard condition, what will be the electrode potential? But if I want to have a not non-standard condition, जहाँ पे temperature कुछ भी हो, and basically we are going to change the concentration in your standard temperature वगैरह change नहीं करते हम लोग ऐसे भी. Okay. So how to calculate the electrode potential for those type of things? So for that we have the Nernst equation. Important thing to about Nernst equation, very important to आप भूल जाइएगा, लेकिन बहुत बच्चे भूल जाते हैं, is that Nernst equation is always written for a balanced chemical reaction. Just give me a second. Yes, Rishita. Sorry, actually there is no light. That is why. हाँ. Now, एक चीज जो हमेशा याद रखनी है आपको, Nernst equation you will write only after writing a balanced chemical equation. So I will, for example, if I have the anode half cell, yeah, a cathode half cell. First of all, let's see if you are having cathode half cell, then what's going to happen? You'll have N positive plus N electron. It will give you metal solid. If you're having this, then you will write the Nernst equation for this one. The Nernst equation will be E of this particular reaction, that is N positive to M, is equal to E naught of the same thing, E naught of Mn positive to metal minus RT upon NF ln Q, right? Or if I'm just writing things, and I don't write down. If you have oxidation reaction, for example, M gives Mn positive plus some N electrons. Then in that case, E of metal to Mn positive will be equal to E naught Mn positive minus RT upon NF ln Q, right? Or if you have a complete cell reaction like this, suppose you have AA plus BB gives CC and CD. In this small a, small b, small c, small d, all of these are numbers, stoichiometric coefficients. So for this, we can write the E naught of this cell, sorry, not E naught, the EMF of this cell will be equal to whatever the E naught of this cell is minus RT upon NF into ln Q. Now you can see that the reaction is changing in this. What we are changing, we are only changing the E naught. If it is oxidation half cell, we are writing the oxidation E naught, reduction K, reduction E naught. If it is complete cell, then we are going to write complete cell reaction. Is this clear? Yes, please tell me. यहाँ तक आप समझे ऑक्सीडेशन हाफ सेल के लिए भी लिख सकते हैं, रिडक्शन हाफ सेल के लिए भी लिख सकते हैं, एंड वी हैव टू राइट मोस्ट प्रोबेबली ज्यादातर आपको किसके लिए लिखना पड़ेगा फॉर द कंप्लीट सेल रिएक्शन, राइट। अब यहाँ पे क्या चीज क्या क्या है उसको देख लेते हैं, ध्यान से देखिए। दिस इज अवर स्मॉल इक्वेशन, बट इन दिस वी हैव Q, that is the reaction quotient. Reaction quotient. This is from equilibrium, that is equal to the concentration of product to the power of their stoichiometric coefficient divided by the concentration of reactant with the power of their stoichiometric coefficient. याद है ऐसा कुछ a की पावर, मतलब ऐसे लिखते थे c की पावर c into d की पावर d divided by a का पावर a divided by b का पावर b. You remember this from equilibrium, something like this?
Yes, sir.
है ना, तो वो है यहाँ पे reaction quotient. Now R and temperature. P is what? P is obviously temperature in Kelvin. R, it is the gas constant. N is the number of electron that is being used. F क्या वो बता देते पहले. F is the Faraday's constant. Whose value is approximately 96500.
So should I write that?
अभी अभी पहले सुन लीजिए उस पर. N is the number of electron. E naught is the E naught cell, and this is EMF of the cell. लिख लीजिए अब.
Done, sir.
No, but we are not going to use this in its complete form. We are going to plug in the values of different things, and then we are going to use a modified Nernst equation. But first a change होगा. It will help you also at 25 degrees Celsius or to 98 Kelvin. That is the room temperature. 25 degrees Celsius or to 98 Kelvin, and convert natural log to common log. Then what's going to happen? The E cell will be equal to E naught minus 2 point, and plug in the value of R also. 2.303 multiplied by 8.314 into 298. 2.303 is here because of converting ln to log. This will be divided by n upon n into Faraday's constant 96500. Instead of instead of ln, I am going to write log. This is base 10. Concentration of product, the power, its stoichiometric coefficient, divided by the concentration of reactant to its power, the stoichiometric coefficient. Okay. Now, when this whole thing, if you multiply and divide and do all the calculations, this E will be equal to E naught minus 0.059 divided by N. So 591 However, we are going to use generally 0.06 or 0.059 only. 0.591 use it will be log of product to the power of P divided by reactant to the power of R. Copy कर लीजिए please. Let me know if you're done.
Yes, I'm done.
फिर एक तो नोट्स लिख लीजिएगा. For aqueous solutions, concentration is taken in molarity. For gases, pressure is taken in atm or bar. For pure solids, concentration is taken as 1, है ना. अगर आपको याद हो, इक्विलिब्रियम में भी कंसंट्रेशन को हम लोग 1 लेते थे, अगर प्योर सॉलिड, प्योर लिक्विड और प्योर लिक्विड, ठीक, इनके लिए. जनरली लिक्विड तो नहीं आएगा सॉलिड्स का, लेकिन आपको देखना पड़ेगा, सॉलिड्स बार बार आएंगे, है ना. चलिए, विल डू अ क्वेश्चन, उसका आप कीजिएगा कुछ, ठीक है. सो प्लीज राइट विथ मी. Calculate the EMF of following cell. Calculate the EMF of following cell at 298 Kelvin. Fe to Fe2 positive, and यहाँ पे concentration दिया हुआ है इसका Fe2 positive 0.0 molar, and then they have given H plus to H2, that is 1 bar, and slash working because inert electrode, and E naught is given as E naught of this complete cell reaction is given as 0.44 volts. ठीक है, देखिए इसमें क्या करना है, सबसे पहले वी हैव टू राइट द chemical reaction, है ना. Without chemical reaction we cannot write the Nernst equation. Nernst equation is written only after the writing of chemical reaction. Right. अगर आपको थोड़ा सा याद हो, this is reactant, this is product, this is reactant, this is product. This is inert electron which is not going to take part in the reaction. तो reaction में क्या क्या है,
Yes, sir.
Fe plus H plus gives Fe2 positive plus H2. Right. I will balance the atoms first. So have one iron. Here we have two hydrogens. प्लस टू चार्ज, यहाँ पे भी टू प्लस चार्ज है ना, यहाँ पे भी टू प्लस चार्ज, इधर भी टू प्लस चार्ज. राइट. तो एंड द नंबर ऑफ इलेक्ट्रॉन विल बी इक्वल टू हाउ मच, टेल मी प्रेषिता. इन सब चीजों का प्रैक्टिस किया ना हम लोगों ने. नंबर ऑफ इलेक्ट्रॉन विल बी इक्वल टू,
The oxidation state times the number of moles, right?
हाँ यस करेक्ट. तो किसी एक आयन को पकड़ो, आयरन या हाइड्रोजन किसी को भी पकड़िए.
2.
करेक्ट. नाउ वी कैन राइट E इज इक्वल टू, देख लीजिए एक बार उसके बाद लिखिएगा, ठीक है ना. E नॉट माइनस 0.0591 डिवाइड बाई 2 log ऑफ कंसंट्रेशन ऑफ प्रोडक्ट. प्रोडक्ट में कौन है, concentration of Pb2 positive multiplied by the pressure of H2 divided by the concentration of Fe multiplied by the concentration of H plus to the power 1. H plus का concentration नहीं दिया है, H plus का लिख लीजिएगा 1 मोलर है ना concentration. The concentration of H plus to the power 2, because here we have stoichiometric coefficient 2. Now I will plug in the values. E naught is what? E naught is given as 0.44 minus 0.0591 0.0591 divided by 2 log of, what is the concentration of Fe2 positive? See in the cell
0.01.
representation. Yes, very good. इसको लिखिए, आप लिखिएगा 10 to the power minus 2. Okay, fine.
Yes,
It will
sir.
help you. I will, ठीक है, multiplied by pressure of H2 is how much? 1. And concentration of iron concentration I will take as 1 because iron is a pure solid. Concentration of H plus is also given as what? 1 square. Overall, it will be equal to 10 to the power minus 2 will be equal to how much? हाँ बोलो, मैथ्स क्या ना, मैथ्स है आपका. हाँ
Oh,
निशिता.
-2.
हम्म वेरी गुड. कुछ तो फायदा हो मैथ्स लेने का. ये क्या आ गया, पूरा -2 आ गया. सो दिस होल वैल्यू बिकम्स -2, है ना. देख रहिए जी सर. 0.44 minus 0.0591 divided by 2 multiplied by -2. So 2 and 2 will get cancelled. Minus and minus will become positive, and you will get the answer as 0.44 plus 0.0591, which will be equal to 1 9 as it is. 4 plus 5 will be 9, and then 4. This many volts. So this is how you have to do. हो जाएगा, बताइए.
Yes, sir.
Copy this down. Done.
Yes, sir.
एक सवाल कर लेंगे सबसे आप
I'll try, sir.
कर लीजिएगा ना। हाँ, तो इस सवाल में देखेंगे, देखिए एक चीज और आपको नहीं रहेगी, ई नॉट डायरेक्टली नहीं दिया रहेगा, ठीक है। आई एम राइटिंग द क्वेश्चन, कैलकुलेट द ईएमएफ ऑफ फॉलोइंग। एक सवाल जरूर आता है हर बोर्ड के, कोई भी सेट को ले लीजिए। वन क्वेश्चन इज obviously always there from last equation. We have aluminium to aluminium P positive, and the concentration is given 0.001 molar. We have salt bridge, nickel 2 positive, 0.1 molar, 2 nickel, this solid, and they have given E naught of nickel 2 positive, 2 nickel, minus 0.25 volts, and E naught the reduction potential है ना यहाँ पे, और यहाँ पे reduction potential of aluminium P positive to aluminium is minus 1.66 volts. So from the E naught of different half cells, you have to calculate the E naught of cell, है ना। E naught cell तो निकाल सकते हैं आप, है ना।
Yes,
कीजिए
sir.
जरा, एनोड रिएक्शन कैथोड रिएक्शन वगैरह सब लोग कर सकते हैं, हो जाएगा। So just do this. I will be back in a few minutes. Okay, 1 or 2 minutes. ठीक है, तो कीजिए आराम से। Let me know if you get stuck.
Yes, sir. I'm still doing it.
Okay, please do. Let me know if you need any help.
Okay, sir. So I'm getting the like the equation as 1.41 minus 0.0591 by 2 into minus 7.
7. ये देखते हैं. First of all, you must have written the
The equation.
equation. So equation will be aluminium plus nickel 2 positive will give you what? Aluminium 3 positive plus nickel. Right? Yes or no? ये सही
Yes,
है?
sir.
बताइए. Then I will multiply 3 here, 3 here, 2 here and 2 here to make the charge balance. सही है?
Yes, sir.
नहीं balance. इतना किया आपने सही? Number of electron is 6.
I forgot to balance it, sir.
अच्छा ठीक है, कीजिए फिर यहाँ से कीजिए. अच्छा ई नॉट कितना है आपका? ई नॉट
0.4, sorry, 1.41 volts.
1.41 ना. ठीक है. कीजिए अब कीजिए दोबारा।
So the like the react AABB by CCVD will be AL 3 plus, I mean AL whole raised to 3, right?
टू, एल होल रेस तो टू ना, स्टोचियोमेट्रिक कोएफिशिएंट देखिएगा ना।
AL whole raised to 2 and NI whole raised to 3.
या करेक्ट।
Sir, is E 1.604?
नहीं, can send the answer on my WhatsApp.
Yes, sir.
निकल का कितना लिया आपने? 0 10 to the power हाउ मच?
-1.
एंड पावर?
2.
पावर 2 होगा। देखो, लुक यहाँ,
Yeah,
वहाँ तो सही लिखा आपने, निकल 2 + 10 to the power 3, है ना?
it's 3. So it'll be, yeah, 3 and 3,
CNC नहीं हुआ कुछ है भाई? CNC
6 and 3.
हाँ, -6 एंड +3 ऐसे ही होगा ना शायद, राइट?
Yes, sir.
हम्म।
But
देखिए, हाँ बोलिए बोलिए।
we can cancel after doing -3 log 10. We can cancel -3 and 6, but we can't divide 0.0591 into by 2. So we only get fractions.
Why you cannot divide 0. Why will you not divide? You cannot divide 0.0591 by 2। हाँ, इतना मिल रहा है ना आपको, देखिए हम बताते हैं आपको कितना मिल रहा होगा। यू मस्ट बी गेटिंग E विल बी इक्वल टू E नॉट, E नॉट क्या लिख रहे हैं, डायरेक्ट ले लेते हैं, 1.41 -0.0591 डिवाइड बाई 6 एंड द पावर आई विल गेट हियर -3 आपको मिल रहा होगा, राइट? ये सुनो, ऐसे ही मिल रहा है।
Yes, sir.
हाँ बताइए। तो 3 and 6 2 सा, this will be equal to 1.41 प्लस हो जाएगा ये 0.0591 डिवाइड बाई 2। यू कांट डिवाइड दिस नंबर।
0.